Hello, my name is Dennis McCallum, and I'm very pleased to be here today. You kind of have my bio in your packages, but during my career at Northrop Grumman, I've been with Electronic Systems at corporate and at the Information Systems, where I helped develop software for radars that tracked missiles coming off aircraft, situational awareness displays that looked at satellites, and looking at increasing the time of identifying signals for some of our electronic warfare systems. About 18 years ago, I started to look at resilience in large radar systems while at Electronic Systems. Shortly thereafter, moved down to the Information Systems area and helped start the first cybersecurity group at that time. This all brings me to today, where I'm a distinguished technical fellow in our cyber division, an instructor in the Northrop Grumman Cyber Academy, where I helped co-design some of the curricula, and a member of the Advanced Cyber Technology Center. My expertise, as Sean said, is primarily in defensive cyber operations and biometrics. I guess the better way of putting this is I'm the old guy, which everybody says was distinguished with a more politically correct term. But today I really want to turn the tables on you for a change, give you an idea what it's like to sit in a cyber operations center, and do that by showing you some of the things that you may not be thinking about in this domain. Things we've developed that make your job as a cyber defender a lot easier and more manageable. And I'm going to give you some insight into three areas that pop up all the time and introduce you to the way we've been working to address those three problem areas, and that's the timing issue, being able to visualize architecture, and how we're providing training. And there will be a quiz, so stay alert. So why do you need cyber training in the first place? What does a cyber defender really do? I mean, what's your daily job here? So for this class, let's all be those frontline cyber defenders that are sitting there looking at this information that's hitting you. Think tanks and media companies present a lot of analysis on what the state of the practice and the state of the art is at the present time. More and more things are coming online, and they're getting connected, and that gives us this big data problem. And at the same time, we've got the threats that give us the variety, velocity, and volume of information that we get to process out there. The demand for the cyber analyst is increasing, but the jobs tend to go unfulfilled because there are just not enough skilled people to be there. So as you sit down at your terminal this morning, you're looking at these kinds of odds. The threat kind of has numbers stacked in their favor. You have a 1 in 2 chance of getting enough information to be able to do anything. The breaches are becoming more extensive, the frequency is increasing, and we really have a time problem here. We got a lot to do, and the stack just keeps growing for us. And that leads to a conclusion here. Chances are you don't have enough time. The number of attacks per week is increasing, but your staffs remain relatively the same. So the workload increased faster than you expected it to, and it's taking longer to resolve things. There's a well-known way the adversary goes about designing and developing a targeted attack. And look at the axis here at area number 2. This is between 2 and 6. This is where somebody breaks in, and at 6, this is where they actually do the mission. Those are two separate things. And all this time down here, I'm running around inside the system, looking for the defender, or looking for the attacker, because my job is to make sure nothing happens at this point. So let me drive this home a little bit more. For Target, that was a point-of-sale attack. There were 40 million credit cards stolen. Variants of the malware that were used on there were available on the internet for $2,000. The attackers had somewhere between 2 weeks and several months of unmolested time running through the system. $140 million was spent on new point-of-sale terminals and on new cards. Home Depot, 56 million cards compromised. 5 months of unmolested running around inside the system. Estimated repair costs of upward $62 million. For JP Morgan, 80 million account holders had information leaked. Several months of data exfiltration. Everybody was going low and slow there. It took a long time to find it. This is all about money lost. But what if this was lives? What if the radar could not see something? What if the aircraft could not detect something? What if the communication lines were blocked? For starters, this is all about time. We're in the same threat continuum. Does not matter where the final place is, whether it's here or whether it's in an airplane. This is all about the time issue, the time the threat has to be on station, the time that you have and don't have to respond effectively. So the temporal issue is a big one, so let's take a look at this. This is what the threat does sort of at a high level. If you start on the left-hand side and work your way to the right, it's various steps that the adversary will go through to plan an attack, do the proper research, affect the attack, do the mission, take the data out, clean up, and leave. Defenders, on the other hand, sit there and prepare for an attack by looking to see what's out there in the industry, putting together your defenses, monitoring for an attack. When an attack happens, go in, take a look at it, perform the triage, do the recovery, effect some fixes, and go. But what happens in here, if you look at the boxes, there's some undetected time. And what we're all about is trying to take that time away. Where I cannot manufacture time, I can at least affect who gets what time. And I would like to give less time to the attackers and grab more time back for us. So how can I connect these dots faster? Let me give you a little context about the threat. Last year, the Defense Science Board released a report detailing the cyber threat, and it's a very good way of being able to communicate the level of sophistication of the threat among all of us. And if you look at the top two areas, those are the more common kinds of attacks, the ones that have signatures that we know about, and they gradually get more complex to the state actors who are developing completely new vulnerabilities in ways that have become very difficult to imagine. Got it? Okay, pop quiz number one, which tells you there's at least another one. So if you're looking at this, where do you think you would focus? I get to help you out now. Immediate goal is to take time back where you can. If I know everything in this region, and that's, I know the signature, I know what to expect, I know the vulnerability, and I know the fix, why not automate this? But where I need to automate this is in a proper context that I can measure. So what we've done is we've combined this automation with the SANS 20 critical security controls. Now, why did we pick the SANS 20? It was crowdsourced from the US government, from all the CIOs and CISOs, at what their common problems were and what their common solutions were to those problems. It's a measurable baseline. To have automation without having something to measure it against does not give us a point that we know we can depart from. So we've coupled this together. We believe that there's a lot of good use for this type of automation targeted in this area. It frees up the analysts to work in the other areas. We've actually completed a study of 8 different security operations centers and taken a look at their state of automation in that context of measuring. We're in the process right now of preparing and publishing a paper on that, on the findings of that. That'll be out in the next couple of months, so stay tuned for that. So the first answer was automation with threat context and kind of a measurable result. We've been looking at a series of solutions that move on to architecture. Because architecture, if I have a way that I can show structure, that I can visualize the picture for you, and to give you an idea of the layering of what the defenses are, I've increased my communication. If I can show you that in a picture. And that picture could look something like this. We developed the FAN as an approach to show what layered defenses look like. The center section in here shows all the different technologies that are part of a layered cyber defense. On the outside wedges, those are the areas that provide the monitoring and control and the kind of threat analysis you look at before you go in and do all your control. For instance, if you look down the left-hand side of the center, you see IA and CM, identity access and control management. That controls your ability to be authorized to enter those different levels of the system. Okay, got that one? So I have a mechanism here of being able to communicate. So quiz number 2, what do you think that tells you if I was to go show that to you? This is an effective way of being able to communicate an attack. What happened here was I got an alert. My identity access at the perimeter and at the endpoint told me somebody broke in. There's a problem. I fused that alert down here where my data security was and saw that the integrity of the data was a question. And my data loss prevention over here, I noticed something going out. I was able to stop this attack because I knew what was going on. But more importantly, I'll bet you understand it by looking at the picture. And it's a lot easier to understand when you put it in the context of a visual. So we've been using this effectively to talk to our customers and to scan and look at the cyber defenses and have a really good way of see how all these pieces play together. So what else is there besides architecture and automation? How about the right education? We designed the Northrop Grumman Cyber Academy to be a critical component of our company's cybersecurity strategy and to increase the level of both foundational and specialized knowledge in cybersecurity. We want to increase awareness and supplement the many available theoretical courses with real hands-on type courses. Cybersecurity is always on our minds. We are training our employees. It helps our employees think about doing their job better and maintaining a high security profile for anything we design, develop, and deliver. And we do this training in a virtual environment so that we can keep the data real. We have 4 levels of courses: foundational awareness, the basics, advanced study, and simulated application. The courses cover cyber strategy, cyber engineering, and cyber defense. As an example, our Cyber 101 course provides a comprehensive view into the tools and techniques that are used and then ways to go about understanding how they might affect a system. The Cyber Secure Architecture Analysis and Application course has students understand the wide range of direct and indirect requirements for an effective cyber defense solution, and then to map those onto the views like you just saw previously with the fan and communicate those cyber defenses to people. And finally, as we stand up solutions from our research, we develop courseware to help analysts get into the temporal impact. Blue Vector is our cyber intelligence product that brings automation and machine learning to discover in real time the advanced threats that helps the analyst. Remember those tier 3 through 6 we saw in the Defense Science Board report? Targeted right at that. The automation for the first 2, Blue Vector is looking at the last 4. And as we continue to develop these kinds of solutions, we're co-developing advanced curricula within the Cyber Academy to match that. Next year, with our investment program, I expect to stand up some additional architecture, automation, and forensics courses. All right, so another fun fact. I actually did my dissertation on the tangible impact of the architecture course. We went out 6 months after teaching the course to a number of people, see how that went with their customers, those that used those views with the customers, and we got kind of a resounding, hey, this is a pretty cool way to go do it. I kind of understand what's going on. It's helped my ability to communicate. And we got a lot of reasonably decent resonation on it. So we know we are onto something with that. And like I said, we've been using it for quite a while. Basically, we practice what we teach, and we teach what we practice. We are all about time, getting more of it for the defender and taking as much of it as we can get from the attacker. Measurable and contextualized cyber defense, automation, realistic and targeted cyber education, and effective cybersecurity architecture. Just some of the ways Northrop Grumman, and in particular the Northrop Grumman Advanced Cyber Technology Center, is focused on cyber resiliency. Now it's my pleasure to introduce Vern Boyle, our Director of Technology for the Cyber Division and leader of the Advanced Cyber Technology Center. Thank you.